Hi, I'm Miss Hearn. Let's get started. In this video, we're going to continue our discussion about rational expressions and how to simplify them. And we're going to look at some special cases that can come up. Sometimes we'll have to rearrange the order, and sometimes we'll have to identify when we have opposites. So before we get started, I just want to remind you that we can always reduce fractions when we have the same factor in the numerator and the denominator, or when we have opposite factors. For example, if I have 5 divided by 5, that's just going to be 1. If I have 5 divided by -5, that's going to be -1. These are the two ways that we can reduce rational expressions and fractions. So in this first example, I have 2 times x plus 3 over x plus 3. X plus 3 is a factor of both the numerator, the top, and the denominator, the bottom. And x plus 3 divided by x plus 3 is just 1 because they're the same factor. This is going to leave us with 2 times 1 in the numerator and 1 in the denominator, or 2 over 1. But we shouldn't leave it written like that. We should write it as 2 because 2 divided by 1 is 2. So you've seen in the previous video that we can reduce rational expressions in this way by dividing out common factors. Sometimes it's not so obvious that we have common factors because the order is just different. As long as you have addition, not subtraction, you can always rearrange the order of the terms inside of a polynomial. So for example, here I have 8x plus 3 over 3 plus 8x. At first glance, these don't look like they are the same factor. And by the way, I cannot reduce separately, like I can't say 3 goes into 3. Those are terms, not factors. The difference being factors are things being multiplied, terms are being added and subtracted, and addition and subtraction are like glue. These two terms are stuck together. The only thing you can do is to divide an entire factor, the thing in parentheses. So let's see though, isn't it true that 8x plus 3 and 3 plus 8x are really the same thing? Because addition is commutative. We can switch the order here. So this is really 8x plus 3 divided by itself. So it was a little disguised, but in fact we do have common factors. And when we divide a number by itself, that leaves 1. Sometimes it looks like we might be able to rearrange, but in fact we can't, and there's no reducing we can do. And this is one of those cases. You see how 2u plus 5 looks similar to 5u plus 2. But notice that the u's are in the first terms, and so 2 is tied to the u in this case, and in the denominator 5 is with the u. 5 is the coefficient. So even if we were to rearrange by reordering the addition, say in the denominator, these don't match up. This is not the same pair of terms, and this is not the same pair of terms. And the entire expression, the entire factor has to be the same in order to be reduced. So we cannot reduce. We don't have the same factor, and we don't have opposites. All right, now let's look at this one. This is an interesting one. We have v plus 4 in the numerator, negative v minus 4 in the denominator. So at first it doesn't look like we can reduce, but remember I said that we can reduce opposites? Well, here's a perfect example of how that would work. So v plus 4 has a leading coefficient of 1. It's not written, but it's a positive 1, which is what we like. We don't like having a leading coefficient of a negative. So let's factor that out. If I factor out a -1 from both of those terms, what's left behind? Well, you multiply -1 times positive v to get negative v, and you multiply -1 times positive 4 to get -4. So this leaves behind a v plus 4, which is exactly the factor that was in the numerator. So we can divide v plus 4 by v plus 4, leaving a 1 behind, and we're left with 1 divided by -1, or just -1. So we ended up with -1. Why did that happen? Because we had opposites. Notice that in the numerator, v had a positive coefficient and 4 had a positive value as well. And in the denominator, they each had negatives. So in the top, V was positive, in the bottom it was negative. In the top, 4 was positive, in the bottom it was negative. These are opposites. Whenever both terms have exactly the opposite sign from the numerator to the denominator. And so that will always divide out to give you a -1. And so if I had had something like, I don't know, x plus 3 divided by -x minus 3, since these are opposites, you can actually skip the factoring out the -1 part and just go straight to -1. Let's look at this one now. 2x minus 5 over 5 minus 2x. All right, first thing I'm going to deal with here is the order. Now, you cannot switch -2x and 5 and get 2x minus 5. That's a common error. You can't do that. Remember, the 5 is positive. That sign stays with the 5. And the 2 is negative. That sign stays with the 2. But what you can do is you can rewrite it in a different order as -2x plus 5. So if you do that, notice that everything matches up. The x is over the x. The 5 is over the 5. And the only thing that's different from the numerator to the denominator is the signs. In the numerator, the 2x is positive. In the denominator, it's negative. In the numerator, the -5 is negative, and the 5 in the denominator is positive. So these, again, are opposites. Whenever the entire polynomial has all opposite signs from numerator to denominator, the entire thing can divide out and leave you with just a -1. You can prove it to yourself by factoring out a -1. But if you recognize that the terms are all opposites, you don't have to. You can just say, oh, that's going to cancel and give me a -1. So I'm going to write one more example. Let's say that we had 3 times x minus 5 over 4 times 5 minus x. All right, so do we have the same factor where we can reduce and get 1? No, because these don't match up. Watch. This is 3 times x minus 5, and rearranging the order so that the x is first, we're going to have 4 times negative x plus 5. So they're not the same factor. They can't divide to be 1, but are they opposites? Yes. In the numerator, we have a positive x, in the denominator, negative. In the numerator, we have a -5, in the denominator, positive. All the terms are opposites. So we know that they're going to divide out to leave us with -1. Now be careful here. It's gonna leave a -1 behind and a 1. -1 divided by 1 is -1. You can't put a -1, in other words, in both the top and the bottom, because that divides out to give you 1. So whenever you're going to reduce in that way, where there's going to be coefficients left behind, think of it as putting a negative in either the top or the bottom. Doesn't matter which. So for example, if I put the negative in the top, that's going to give me 3 times -1 is -3, 4 times 1 is 4. That leaves me with -3/4. If I put it in the bottom, it'll just be 3 over -4, which is also equal to -3/4. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.